Wanted to show you guys a few examples from the momentum as a guide to thinking problems here in the end. This uses a technique that we've done sometimes in class in the past called proportional reasoning. And so the very last assignment can confuse a lot of people, but it's actually easy enough to do in your head once you realize what to do. All of these involve inelastic collisions, completely inelastic collisions. So we're going to have a mass that's moving, and it's going to hit and collide with another mass, and they're going to stick together and move off. And in every single one, they want to know what the velocity is in the end. So as these two masses move off. And so that's the problem every single time. Every single one of these, the second mass is just sitting there to begin with. So first thing is, in any situation, whether we have m colliding with m, or m colliding with 2m, or 2m colliding with m, our overall mass after we've collided goes up because we've picked up something here. That means our overall velocity's got to go down. So all of these answers are going to be a fraction of v. So here's how we do this. Mass m is coming in at speed v, and it's going to collide and stick with another mass m, and they move off together. So we can do it like this. The momentum before is equal to the momentum afterwards. In the beginning, we had mass m going speed v, and afterwards, we have mass 2m. And so we want to figure out what that velocity afterwards is. How do we know it's 2m? Well, we have 2m's right here. So those masses actually cancel. And so we get v is equal to 2v prime. And if we solve for v prime, we get 1/2 of the original velocity. And this is what you will put into the answer box. So the speed at which these move off with is 1/2 whatever this speed was. If this speed was 10, this speed would be 5. If this speed was 6, this speed would be 3. And think about it too. Here's how you can do it in your head. We know if we double the mass, we went from m to 2m, then we got to do the reverse of that to the velocity to keep the momentum the same. Twice the mass with half the velocity will keep you at the same momentum. So here's how I do these really quickly, and you can do it in your head or writing down on paper really fast. I write down what mass we had moving, and I'll just call that 1m. And then I look at how much was moving in the end. In the end, we have 2m moving. So in the beginning, we had 1 out of 2 of the mass moving. So that means in the end, we'll have 1 out of 2 of the velocity. So if we use that same logic here, you can go through and do the steps like this. On the next one, you can say the momentum in the beginning is equal to the momentum in the end. And we had m moving at v in the beginning, and in the end we have m plus 2m. We have a total of 3m moving. Once again, the masses will cancel, and if you solve for v prime, you'll get v divided by 3, so 1/3 of the original velocity, and this is what you'd plug in for number 2. There, so whatever this velocity was, this velocity here that they move off with will be 1/3 of that. And again, you could have done this right off the bat by saying that we had one mass moving out of the beginning. In the end, we have 3m, so we have 3 units of mass. So if we only had 1/3 the mass moving in the beginning, but now we have all the mass moving, we must only have 1/3 of our original velocity to keep us at the same momentum. So let's just try that actually here and save ourselves some time. In the beginning, this one's a little bit different. We had 2 units of mass moving. In the end, we have 2 and 4 together, so we have 6 units of mass moving. Let's simplify that, and it simplifies down to 1/3. So this one is also 1/3. Whatever the velocity was here, the velocity of the 2m and the 4m moving off together would be 1/3. And that is what you would put in the answer box there. So last one, let's try that same technique here. In the beginning, we had 2m moving, so that is, I'm going to write there. In the end, we had 2m plus m, so we had 3m moving. So we only had, one way to look at it is 2/3 of the total mass moving in the end, so we're only going to have 2/3 of our velocity in the end. So whatever this velocity was in the beginning, this velocity in the end is 2/3 of that.